Hello, my name is Sam, and this video is my Eagle Scout project for the Ann Arbor Ecology Center. My friends and I here are going to tell you about something called green chemistry. Now, what is green chemistry, you might ask? Green chemistry, also called sustainable chemistry, is the science of creating products and processes while minimizing their negative effects on the environment. It focuses on promoting safety and energy efficiency while reducing toxicity. Green chemistry is a proactive approach to pollution prevention. It targets pollution at the design stage before any is even produced.
Green chemistry has 12 principles which help to explain what it really means in practice. The 12 principles of green chemistry are: pollution prevention. It is better to prevent waste than to treat or clean up waste after it is produced.
Safer solvents and auxiliaries. The use of auxiliary substances, such as solvents and separation agents, should be made unnecessary whenever possible and innocuous when used.
Catalysis. Catalytic reagents are superior to stoichiometric reagents.
Atom economy. Synthetic methods should be designed to maximize the incorporation of all materials used in the process into the final product.
Design for energy efficiency. The energy requirements of chemical processes should be recognized for the environmental and economic impacts, and should also be minimized. Synthetic methods should be conducted at ambient temperatures and pressures when it is possible.
Design for degradation. Chemical products should be designed so that at the end of their function, they don't persist in the environment and break down into innocuous degradation products.
Less hazardous chemical synthesis. Wherever practicable, synthetic methodologies should be designed to use and produce substances that possess little or no toxicity to human health and the environment.
Use of renewable feedstocks. A raw material or feedstock should be renewable rather than depleting whenever technically and economically practicable.
Real-time analysis for pollution prevention. Analytical methodologies need to be further developed to allow for real-time, in-process monitoring and control prior to the formation of hazardous substances.
Designing safer chemicals. Chemical products should be designed to fulfill their intended function while reducing their toxicity.
Reduce derivatives. Unnecessary derivatization, use of blocking groups, protection or deprotection, or temporary modification should be minimized or avoided whenever possible.
Inherently safer chemistry for accident prevention. Substances and the form of a substance used in a chemical process should be chosen to minimize any potential for chemical accidents, including releases, explosions, and fires.
Now, where do we apply green chemistry? Numerous products are made in industry to serve various purposes. For each industrial product, there is a chemical process that was developed to create that product.
Green chemistry has been and continues to be applied in industry so as to improve the chemical processes that are used. The chemical processes, as well as the products that are created, may very well have a negative impact on the environment. Green chemistry is used to adjust and analyze the products and processes in a way that minimizes any negative impact on the environment.
Here's an example of why green chemistry and applying it is so important. In 1984, Bhopal, India, there was a pesticide plant. An accident occurred and a ton of water had mixed with 40 tons of methyl isocyanate gas. The exothermic reaction that resulted from this went out of control and 40 tons of the deadly gas was released. In the end, approximately 3,800 people died immediately due to the gas.
Another good and more recent example would be the Elk River chemical spill in West Virginia. Crude 4-methylcyclohexane methanol, MCHM, was released from a Freedom Industries facility into the Elk River. Due to the chemical spill, up to 300,000 residents were left without access to potable water. Crude MCHM is a chemical foaming agent that is used in the processing of coal at coal preparation plants, and it is used to remove impurities that add to pollution during combustion. Green chemistry can help us to solve and prevent a lot of problems.
Green chemistry does not focus on just industrial applications, but any chemical choice. Green chemistry can also be applied in the classroom and can even be taught as its own course. Chemistry is taken a lot as a high school course, and labs are often performed to help students learn about different concepts in chemistry and their applications. Most of the labs involve the use of chemicals that aren't quite as green as one might think. If you go to beyondbenign.org, they actually have green chemistry replacement labs for regular chemistry labs, and we are going to briefly describe and demonstrate a few of them.
We will begin with the redox reaction lab. This lab would be used to show a redox reaction between solid magnesium metal and an aqueous solution of zinc chloride. After taking respective data throughout the lab, the students would calculate the theoretical yield and the percent yield. We have already measured out 0.15 grams of magnesium metal and polished it. Now we are going to measure out 125 milliliters of 0.15 molar zinc chloride into a beaker. We will then add the magnesium strip to the beaker. After having allowed the magnesium strip to react for 20 minutes, we will remove the magnesium strip and wash any solid off into the beaker. We will then set up a funnel system and pour the contents of the beaker through the filter. The procedure of this lab is very similar to the more traditional redox reaction lab that is being replaced. The only main difference is that we are reacting solid magnesium metal with an aqueous solution of zinc chloride, as opposed to reacting copper solid with aqueous silver nitrate. Now you might ask, why is this lab greener than the more traditional lab? Well, silver and copper are heavy metals which are very toxic to humans and the environment, and exposure to silver can have serious health risks. Zinc, however, is much less toxic to life forms, despite also being a heavy metal. The solid magnesium metal and aqueous zinc chloride is a much greener redox reaction than the more traditional one. Now let's move on to the solubility lab. We are going to begin by preparing an ice bath in a 400 milliliter beaker. In a separate 400 milliliter beaker, we are going to add water and then heat the beaker for 5 minutes. We are then going to fill two 100 milliliter graduated cylinders with clear carbonate beverage and seal the tops with parafilm. The next step is to poke an equal-sized hole in each piece of parafilm. Finally, we're going to place one of the graduated cylinders in the ice bath and at the same time place the other graduated cylinder in the hot water beaker. After taking respective measurements and observations, the students would proceed to answer questions about the lab using their knowledge of solubility rules. A lot of labs that are similar to this one use soluble ionic solids such as nitrate salts. Disposal of these compounds has a negative effect on an aquatic environment. When a nitrate is added to an ecosystem, it causes a spike of algal growth and a ripple effect is felt up the food chain. In the worst case scenario, eutrophication can occur. This lab involves the use of clear carbonate beverage, which is a much greener alternative to the compounds that would be used in more traditional labs. So we don't have to worry about disposing compounds that would negatively impact the environment. There is also a replacement for a flame emission spectra lab. Traditional flame emission spectra labs use solutions of toxic metal salts in Bunsen burners. The replacement lab uses candles with colored flames that burn at a much lower temperature than the Bunsen burner. This lab eliminates the preparation and disposal of salt solutions from the procedure. In this lab, students would observe the colored flame with both the naked eye and a diffraction grating.
This concludes the video. For more information on the green chemistry replacement labs here, or on any others, please visit beyondbenign.org. Please also visit Beyond Benign if you would like to know more about green chemistry and/or about getting it taught at your school. And to learn more about how you can take action in your environment, you can go to the Ann Arbor Ecology Center's website at ecocenter.org.